Okay, now we're going to continue our look at the critical path analysis of a network by looking at forward and backward scanning. And so this is a way that we can look at identifying minimum time for a project completion. So that's for the entire project to be completed. We can look at minimum times. We can also calculate the earliest start time for the different tasks within the project. Okay, and we represent that with EST. So the first thing we're going to do is in our network, we're going to divide each of our nodes in half, like this. And then basically we're going to put the start time on the left-hand side of the node, because we're going to be putting finishing time on the right-hand side. So let's start with the start time. So to begin with, we're going to put a 0 because we're starting at 0. That's our earliest start time for task A. Now, task A takes 5 minutes, okay? So 5 minutes is going to be the earliest start time, because this is obviously an immediate predecessor. It had to be completed before these 2 tasks here could begin, or 3 tasks could begin. So the earliest start time would be 5 minutes into the project. Then we have a look at our next ones. So then we've got 4 minutes. Okay, so it's going to take another 4 minutes for B to happen, and D cannot start until B has begun. So if we add the 4 onto our 5 minutes, that means 9 is going to be our earliest start time for D. Then I'm going to have a look at my next node, which can actually go through activity C or activity D. So what I want to look at is, let's see, I should actually be showing you A, B, and D. So that's, sorry, I should actually do that. 5 and 4 and 3. Yeah, which is 12. But we also have A and C, which is 5 and 7. Yeah, 5. Sorry, not 5 and 7. 5 and 2, which makes 7. 5 and 2. So we could go 5 plus the 2, which would make 7. Now what we're actually going to do is we're going to pick 12. Here's why. We need to choose the largest number. And we're going to choose the largest one because we actually need A, B, and D to be completed. So D must be completed before the beginning of E. So C also has to be completed, but that actually will take less time. So A only takes 5 minutes, C's only 2 more, so it can be finished within 7 minutes. But A, B, and then D can only be finished within 12 minutes. So if we started at 7 minutes, these ones up here wouldn't be done. We'd actually still be finishing B. We wouldn't have even started D. We wouldn't be able to start E. So the earliest start time is going to be the largest, okay, the largest of the pathways through. So in this case, 12. Okay, from there, we have a look at E. So basically, E takes 3 more minutes. So that's an entirety of 15. So that is our total completion. So earliest completion time is 15 minutes. For the entire project. Okay, So then we go, okay, that's forward scanning. Yeah, so we've scanned forward through, looking at our earliest start times all the way through. Now, we're going to do some backward scanning. So let me swap colours to green. Okay, green. So here's what we're going to do. We need to start at the end node and we're going to move backwards through the network. Okay, in backward scanning, so what we do is we record the latest start time. So let's go latest start time. Latest start time, LST, you'll see it in the right hand side of the node. So that's the latest time that that activity can start without delaying the project. Okay, so what we need to do is we need to subtract the time of each arc from the latest start time. So we start at 15, okay, because that's our end. And then what we do is we go 15, take 3, which is going to be 12, yeah? Oh, actually, I've gone a little different on this one. Okay, so then we're going to go with 12. Okay, then we're going to roll back a little more. So 12, we're going to take 3. So that makes it 9. We're going to 12 and we're going to take 2. So that makes it 10. 9, take 4. That makes it 5. So if I remember correctly, what we have to choose okay, large number in forward scanning, wrong one, large number in forward scanning, smallest number in backward scanning. So because this is a fairly simple one, we're not actually finding a lot different here. Okay, so, and that's a good hint, so I'll put that over here. So, large number, forward scanning, small number in backward scanning. So when you have a choice of 2, so just like when we were going forward, we chose 12 over 7. It was a bigger number when we were scanning forward, so we had to choose a bigger number. When we are scanning backwards, we need to choose the smaller number. Now that's because when we go backwards, the latest start time is still going to be 5. If we don't start at 5 for B, it's not going to happen. C could actually have a later start time and still finish on time here, but because this section, B and D, take longer, they will have to start at 5. So, okay, so the first thing we're going to do, let me take this network off my face. The first thing we're going to do is forward scan through the network. Okay, so we're going to start at 0. Now this one takes 5 minutes. Then we've got 5 and 4, which is 9. 5 and 5, which is 10. Okay, and then we've got another 5 here, so that would be 15, or 9, 10, 11, 12. So 15 or 12, remembering that we need to go with the bigger number, so that would be 15, and then 2 more, 17. Okay, so that's forward scanning. Backward scanning. Now to backward scan, we're going to put 17 in last, yeah? And then, because that's the earliest completion time for the project, okay? Earliest time it can finish. Then we're going to work backwards. So 17 take away 2 is going to be 15. Then we're going to go top node. So 15 take 3 is 12. Yeah. 15 take 5, 10. Then we'll go this way. So 12 take 4 is going to give us what, 8? But then 10 take 5 gives us 5. So remember, when we're backward scanning, we want to choose the smallest number. So 10 take 5 is 5. Let me just write these in. That's 17 take 2 is 15. This way we went 15 take 3 is 12. This way I went 15 take 5 is 10. Then this way I went 12 take 4 is 8. But this side, 10 take 5 is 5. So when I scan backwards, 8 and 5, I need to choose the smallest number. Biggest number when I'm forward scanning, smallest when I go backwards. And then 5 take 5 is going to give me 0. So I'm still starting at 0. That's my earliest start time. So all the way, I've actually drawn my network where I have the earliest start and latest start. Okay, so basically, float time is our last little section. But before we start float time, I just want to make sure that you understand where all these come from. So let's just get rid of some of these. Okay, so this is the latest start time of B. It's also the latest finish time of A. This is the earliest start time of B. Then we've got our earliest start time of D, earliest start time of F, yeah. Latest finish time of B, latest start time of D. This one is our latest finish time of D and latest start time of F. So it's important that you actually remember these acronyms, okay, and that you can understand what these numbers actually mean. This is the earliest time that B can start. This is the latest time B can start. As you can see, for some of them it's no different, but for this one, D can start at 9 minutes, but it can start as late as 12 minutes. There's a little bit of leeway there in how long it has before it has to be done.